Hi, welcome to DABblocks. In this video, we will learn about Ethereum Virtual Machine, that is EVM. If you are new on the channel, my name is Himmat. Here we learn all fundamental concepts and practical development of blockchain technologies. So, if this is something helpful to you, then press the like button and subscribe to the channel. Also press the bell icon to get notified whenever we upload a new video. Let's get started. Ethereum Virtual Machine. The Ethereum Virtual Machine, that is EVM, is the runtime environment for smart contracts in Ethereum blockchain. EVM is the part of Ethereum blockchain that handles smart contract deployment and execution. The job of EVM is to update the Ethereum state by computing valid state transition, which is nothing but executing smart contract code. Let's see how it works. Please watch this video very carefully. It will be little technical, and by the end of this video you will understand how EVM works internally. As we know, Ethereum has two types of accounts: externally owned accounts, that is user accounts, and second is contract accounts or smart contract accounts. When there is a transaction request for contract creation from externally owned account, then it will create a new smart contract account with its code and storage. Smart contract is an immutable computer code called EVM code. Now we have a new smart contract on the Ethereum blockchain represented by unique 160-bit address. Let's see how this smart contract get executed, and for that we have Ethereum virtual machine to run a smart contract. EVM architecture. We have seen each contract account has first EVM code. EVM code is immutable code stores in non-volatile virtual ROM, that is read-only memory. Second, account storage. It stores hash of the root node of Merkle Patrica trie. It is a persistent data between two transition states, and by default it's empty. If you want to know more about accounts and transaction, I would recommend you to watch my previous video on Ethereum accounts and transactions. You can find that link in the description below. EVM has machine state. It is volatile in nature. Machine state contains one program counter, second gas, third stack memory, fourth memory or volatile memory. We will discuss each of these components in detail. Memory or volatile memory. EVM maintains fetch memory in each message call or transaction. This memory is linear and can be addressed at byte level. Memory reads are limited to 256 bits width, and while writing it should be either 8 bits or 256 bits wide. Memory can be accessed with mstore, mload instructions. Memory is expandable, and at the time of expansion, gas must be paid. Gas cost will be much higher as memory grows larger. Stack memory. EVM is a stack machine. It has maximum of 1024 elements, and each element is 256-bit word. Access to stack is limited to top 16 elements. It is possible to swap top element to any of the below 15 elements. This works similar as stack in data structure. You cannot access any deeper elements without removing top elements from the stack. Stack can be accessed with many instructions like push, pop, copy, swap, etc. Gas. Gas is required to execute smart contract. Gas should be paid in Ether. Program counter. Program counter is used to manage memory addresses of the opcodes to be executed next. Let's understand EVM execution model. EVM executes operations from stack. It receives instruction from EVM code, and with the help of stack instruction like push, pop, it executes the operation, and while executing each operation it checks for gas available. If gas is available, then only it will execute that operation, else it will fail with out of gas exception. Program counter is used for providing next operation memory address from EVM code. Stack always have access to the memory and the storage. memory is used as per operation type, and at the end of EVM execution, it will update the account storage with the new transition state. Now let's understand what will happen when one smart contract account send a message call or send instructions to other account. Message call. EVM can send message call from contract account to other accounts. It can be either externally owned account or other contract account. Message call depth should be maximum of 1024 elements, which is same as stack memory. Message call is triggered by call operation or instruction from the stack. Message call sends call instruction to other EVM. The other EVM perform the same operation as we have mentioned in EVM execution model and return instruction output or the value back to the first EVM. Then that first EVM start executing next operations from the stack. EVM errors or exceptions. First, when EVM code contains invalid instruction, then it will throw an invalid instruction exception. Second, out of gas exception. When transaction submit with the less gas than the actual required gas, then it will throw an exception. Third, stack underflow exception. This is again our data structure concept. When EVM try to remove item from empty stack, it will throw this exception. EVM instruction sets. Instruction set is a 256-bit operation. Instruction set contains first arithmetic operations. For example, add, multiply, subtract, divide, less than, greater than, etc. etc. Second, bitwise operations or logic operations. For example, AND, OR, XOR, NOT. Third, stack operations. For example, push, pop. Fourth, hash. For example, SHA-3. Fifth, copy of input data or code. For example, call data load, call data copy, code copy, ext code copy, that is external code copy. Sixth, process flow operations. For example, stop, jump, program counter, and there are many such other instruction sets. EVM code generation. To write a smart contract code, we can either use Solidity or Viper. In both the cases, compiler will convert the source code to the EVM code. Thank you for watching. Please like and subscribe to the channel, and I will see you in the next video.